Hello guys, welcome back to the Quantity Surveying workshop and to another video. In today's video, still on measurements for the columns, we are going to be measuring the reinforcement bars inside the columns as well as the stirrups. So don't go anywhere, stay tuned and enjoy the video. Now, how do we measure our reinforcement bar? Reinforcement is measured in what? Tons. So to measure reinforcement in tons, you need to go and check what is the weight of your reinforcement, and I give you a special formula to calculate the weight of your reinforcement in kg, and it is d square all over 162. Now, as you all know, the unit for the weight is kg per meter. So just a quick hint: anytime you are told to measure something in tons, go and check the unit of the unit of the steel member. If it is kg per meter, what you are going to be measuring is in linear meter before you convert it to kilograms. If it is kg per meter square, what you are going to be measuring is in meter square before you convert it to kilograms and then to tons. I don't know if that makes sense. So our weight is kg per meter. That is why we always calculate our reinforcement in linear meters first before we convert it to kg and then convert it to tons. Please keep that information, it is very important. So now, how do we measure for our reinforcement bars in the ground floor? So now, let me take you to the drawing. So if you look at this drawing, from this point, the top of the oversized concrete, you can see that there is a black thick line moving up and ending at this point, right? That is the reinforcements that is going to be placed in the column for the ground floor. So what we are going to be doing now is that we are going to be looking for the length of this reinforcement. And how do we get the length of this reinforcement? We were told that from here to here is 3,150. In between this point, there is a dimension of 75 mm, and then from here to here, which is the extra, is 750 mm. We are going to be adding them together, and it will give us the length of this reinforcement. So after getting the length of one, you will now go to the section and determine how many reinforcements are inside the column. And as you can see here, you can see that they've given us 4y16, meaning that there are 4 number of that length of reinforcement inside the columns. I don't know if that makes sense. So we'll now move towards column 2. So as you can see, this is column type 2, and column type 2 is different from column type 1, because if you look at this, from the top of the oversized concrete down to the top of the suspended floor, you can see that the reinforcement does not continue to the first floor. Why? Because the reinforcement has been terminated inside the suspended floor. Now, if you go to the site often, you will notice that there are some cases where the details or the plan in your ground floor is totally different from the plan in your first floor. Now, ask yourself a question: if there are changes in the design of the ground and first floor, it means that sometimes there could be changes in the orientation of the columns. Now, the reason for that changes is either they changed the blockwork orientation, or they terminated some columns. So as you can see, this column type 2 that you are seeing here, you will not be seeing it in the first floor because they have all been terminated. You can see it ended here inside the oversized concrete. That is what termination means. So how do we calculate for this bar that we have here, this reinforcement? We are told that from here down to this point is what 3,150, and as you can see, the reinforcement is inside the oversized concrete. So we're going to be minusing concrete cover of what 50, so that we can get the reinforcement bar from this point down to the center point, and then we can now add an extra for the bend. Let's say an extra of what 200 mm. That would suffice. So when we add that 200 mm, it will give us the length of this bar. I don't know if that makes sense. Similarly, you check for what the number of the reinforcements inside this column, and as you can see, they've given us it is what 4y16. So it is 4. The y16 reinforcement would be what 4 in what number. Moving towards column type 3. And as you can see, for column type 3 is also quite different from what we've been seeing before. So now let's look at column type 3. You can see that if you trace this reinforcement, you can see that it went straight, then it bent, and then pushed up. So it means that this column type 3, the position of column type 3 in the first floor has what changed, because it was bent and then it pushed up for the what continuation. I don't know if that makes sense. So now, how do we now measure for this type of reinforcement? All you need to do is this. The dimensions are already in the drawing. So now, what we need to do now is to, since we know that from here to the top of the wall suspended floor is 3,150, we are now going to minus concrete cover for this what point here, so that we can enter into the what oversized concrete. So whatever we have, we're now going to be adding this bend, which we've given as what 767. After adding this bend, we'll add the what concrete cover, so that we can get to the top of the oversized concrete. After adding the concrete cover, we're going to be adding this 75. After adding this 75, we're going to be adding what the extra, which is what 750. Doing that, you've gotten the what length of this what reinforcement bar. I don't know if that makes sense. Similarly, you check the number and they are what 4y16. That's 4 in number. The same thing with column type what 4. We've treated how to get something like this for column type what 5. So column type 5 and column type 2 are what similar. So we've already treated that. But the only difference between column type 5 and column type 2 is, if you look at this, how many do we have here? 6. So we're going to be having 6 number of this y16 reinforcement inside this column. So similarly, column type what 6. We've already measured, or I've already told you how to go about the measurement for this straight bar here. So it is the same thing. The only difference now is in the number. So the same thing for column type 6, right? Column type 6 is similar to what column type 1. I've already told you how to come about the measurement for this straight reinforcement. The only difference now is in the number of the reinforcements inside column type 6, and as you can see, they are what 6 in what number. So with this, we can now what measure for the what reinforcement. So for the reinforcement bar, we are going to be determining the what length of the what reinforcement. Sorry, pardon me for bending the paper like this. I am left-handed, so I don't know, trying to make the paper straight is kind of uncomfortable, so please pardon me. So the length of the reinforcement bar, we're going to be starting with what column type 1. So for column type 1, like I said here, if you look at the drawing, you can see that what we have this dimension from here down to this point as what 3,150. So we're going to be adding this 75 and we're going to be adding 750. So 3,150 plus what 75 plus what 750 is going to give me what 3,975. So it means that the length of this reinforcement from here down to this top here, from here you can see this thick line from here down to this point here is what 3,975. So with this we'll now what measure 3.98 multiplied by how many number of the reinforcement do we have? You can see it is what 4 in number, so multiplied by what 4. So what we just did here would be for what 1 column, but we have 7 numbers of this column type 1 in the ground floor, so we'll now multiply it by what 7. So when you do the math, you're going to be having 111.44 meters, and then you close. So doing this, you measured for what the total number, the total length of reinforcement for column type 1, and it is what Y16. Everything that you are going to be using here in your ground floor is what Y16. Let me write it here. Y16. So we'll now move towards column type 2. So for column type 2, how do we get the length of column type of the reinforcement? How do we get the length of the reinforcement for column type 2? All we need to do is this. Since we know that from here to here 3,150, we minus what concrete cover and then we add bend, like I said before. So the length is what 3,150. So we'll now less what concrete cover of what 50. After lessing concrete cover, what do we have? We have 3,100. So we're now going to be adding what bend of what 200. So that would be what 3,300. So this will be the length of this reinforcement that you are seeing here, this straight and what terminated reinforcement for column type 2. So they are 4 in number, so you now measure. So it will be 3.30 multiplied by what 4 number multiplied by what the number of column type 2 we have in the ground floor, and it is what 8 in number. So we'll now what close. So when you do the math, you are going to be having what 105.60. So next will be what column type 3. So how do we measure column type 3? You can see that column type 3, like I said before, is quite different from column type 1 and 2. So what we need to do now is that since we know that from here to here is what 3,150, we will less concrete cover because it is inside the suspended floor. So we will now add 767, and then we will now add concrete cover back, add this 75 here, and then add 750. So doing that, we'll get the length of that reinforcement. So we can now measure. So the length is what 3,150. So we're now going to less concrete cover, which is what 50. When you do the math, you have 3,100. Then we'll now what add the bend, and as you can see, the bend is this 767. So after adding the bend, we will now add concrete cover again, which is 50, and then we will now add 75, which is this 75, this small 75 here. And then we'll now add the remaining, which is what 750. So when you do the math, you are going to be having what? 4,742. So 4,742 is the length of the reinforcement for what? Column, the length of one reinforcement in column 3. So we're going to what? Measure 4.74 multiplied by what? How many number do we have? As you can see, they say there are 4 in number. So multiplied by 4 multiplied by the number of column type 3 we have. And column type 3 is how many in number? 4 in number. And then you now what? Close. So when you do the math, you are going to have 75.84 meters. So next will be what? Column type 4. So for column type 4, as you can see in this drawing here, you can see that column type 4 is similar to that how you measure that of column type what? 3. So the only difference now is that column type 4, the bend is what? 804. So now we're going to be what? Measuring. So the length, we have 3,150 for less concrete cover, which is what? 50, and that will give us what? 3,100. After that, we'll add what? The bend, which is what? 804. After that, you add concrete cover again, which is what? 50. And after that, you will now add the 75 and then the extra over 750 that will show in the first floor. So when you do the math, you're going to be having 4,779. So this is this for what? One length of the reinforcement inside column type 4. And as you can see, they say they are having a number 4 in what? Number. So you now what? Book 4.78 multiplied by what? 4 reinforcement inside one column multiplied by what? 3 number of what? Column type 4. And then you now what? Close. So when you add, do the math, you're going to be having what? 57.36 meters. So next will be what? Column type 5. So for column type 5, it is similar to how we measured what? Column type 2. So we'll now bring it back. Column type 5, the length, as you can see here, the length is what? 3,150 less concrete cover and add bend. So 3,150 less concrete cover, which is what? 50. We're going to have what? 3,100. Then you now add bend of what? 200. And that's going to be equal to what? 3,300. And then you close. So 3,300 will be the length of what? The one reinforcement for column type what? 5. So you now what? Book 3.30. How many reinforcement do we have in column type 5? Like I said before, there are what? 6 in number, as you can see here. So multiply by what? 6 multiplied by what? How many column type 5 we have in the drawing? In the ground floor, 2 in number, and then you now what? Close. So when you do the math, you're going to be having what? 39.60. So the last one we're going to be looking at is what? Column type 6. So column type 6, as you can see here, is the same straight bar as we have in column type 1. So we're going to be doing the same approach here. So the length is 3,150 we will add this 75 and 750 to get the total length of that bar. So 3150, we will now add what 75, and we will now add 750, and that's going to become 3975. So 3975 will be the length of this straight bar. So we can now measure 3.98 multiplied by as you can see, there are how many bars here? 6y16. So in one column there will be 6 reinforcements inside. So and column type 6 is 1 in number. So when you do the math, you are going to be having 23.88. So after doing this, you are going to be adding everything you have in your squaring column to get the total length of the reinforcement for all the columns in your ground floor. So we're going to be adding 111.44 plus 105.60 plus 75.84 plus 57.36 plus 39.60 plus 23.88, and we're going to be having 413.72. So 413.72 meters is the total length of the reinforcement for all our columns in the ground floor. But reinforcement is not measured in meters, it is measured in tons. So we have to convert it to tons. So to tons, we are going to be having 413.72 meters multiplied by Now remember, the reason why we are adding everything together is because all the reinforcements used at the ground floor were y16. Assuming there were different reinforcements, we are going to be separating those. We are going to be grouping those reinforcements based on their diameters. So we only have only y16 here. That is why we are adding everything together. Assuming there was a y10, we'll separate y10 separately. Assuming there was a y8, we'll separate that one separately. So now, because this is only y16, we added everything together. So we need to get the weight of y16 reinforcement. And I give you the formula, g squared all over 162. So 16 times 16 divided by 162 is 1.58 kilogram per meter. So it means per every meter the reinforcement is going to be weighing 1.58 kilogram. And now we have 5.13, and now we have 430.72 meters. So we need to find the total kg of this by multiplying them. And we're now going to be having 653.68 kg. Remember your physics, meter will cancel meter, so what we're left is kg. So we'll now divide this by 1000 to convert it to tons. So in tons we'll be having 0.65 tons. So doing this, we'll measure for your reinforcement inside your columns in tons, and then you now describe high tensile steel bar in columns. So doing this, we measured for our reinforcement. So the next thing we're going to be looking at will be the stirrups. So it is not new to, you are not new to links and stirrups, right? Because we measured it in our previous video when we were treating for the columns inside the foundation. So we're not going to be doing any vigorous calculation here because we've already determined what is the total length of our stirrups in our previous calculations. So if you want to learn how to measure the length of your stirrups, please go and refer to the video where I measured taking off measurements for the stirrups in the starter columns. So now, if I bring back the document, you can see this is the calculation that we did. So all we need now is to get the length of the stirrups that we've already calculated. You see, we've already done that, adding the bend and all those good stuff, and the total length we had was what? 0.96 meters, 960 millimeters. And I told you that column type 1 to 4 are what? The same specification. So it means that the links inside column type 1 to 4 will be what? 0.96 meters. So with this we can now what? Measure. But the only thing that will differ would be the number of what? The links in the ground floor. In the foundation there were 7 in number, as you can see here, but in the ground floor there are what? 16 in number. So that is the only difference. So with that we can now what? Measure. So for the stirrups, we know that the length for column type 1 to 4 is equal to what? 0.96 meters, which is 960 mm. So with this we can now what? Book by what? Starting with column type 1. So the length is what? 0.96 multiplied by the quantity, which is what? 16, multiplied by the number of column type 1 we have, which is what? 7 in number, and then we'll now what? Close. So when you do the math, you are going to be having what? 107.52. So next will be what? Column type 2. We do the same thing, 0.96 multiplied by what? 16. As you can see in the drawing here, they said that the links would be spanning along this distance, and they are what? 16 y10. The stirrups are y10. Let me just write it here, y10, and 16 in number. So multiplied by the number of column type 2 we have, which is what? 8, and then you what? Close. So when you do the math, you're going to having what? 122.88 meters. So next is what? Column type 3. The same thing, 0.96 multiplied by what? 16 multiplied by the number of column type 3 we have, which is what? 4 in number, and then you close. So when you do the math, you are going to be having what? 61.44. So next is what? Column type 4. 0.96 by what? 16 by what? What is the number of column type 4 we have? 3 in number, and then you what? Close. When you do the math, you are going to be having what? 46.08 meters. So doing this, we measure from column type 1 to 4. Now we're not going to be doing it with the different ones, which is column type 5 and column type 6. So column type 5, we were told that the dimension is what? 300 by what? 300, as you can see in the drawing here, right? And we calculated the length of the links for that one to be what? 1240. So we are still going to be bringing it back here. So all we just need to do now is to measure. The length is what? 1240 mm. So we'll bring this back, 1.240, that's 1.24 multiplied by what? You can see they said there was 16 in number also for column type 5. 16 in number. and column type 5 are how many in number? 2 in number. So multiply that 2. So when you do the math, you're going to be having what? 39.68. And then the last one on the list is what? Column type 6. And column type 6, the dimension is what? As you can see here, 230 by 381. And in our previous video, we calculated it to be the length of the stirrups to be what? 1263. So we'll bring it back. Length is equal to 1263 millimeters. So we can now book 1.26 multiplied by what? 16, as you can see here, 16 white 10. And it is 1 in number, so we're going to be leaving it that way. So when you do the math, you're going to be having what? 20.16 meters. So doing this, we measured for what? All the stirrups in our what? Ground floor. So we'll now find the total. So after adding everything in our squaring column for the stirrups, we're having what? 397.76 meters. But reinforcement is not measured in meters, it is measured in what? Tons. So to tons, we're going to be having what? 397.76 multiplied by the weight of what? Y10 reinforcement. So it will be what? 10 square divided by what? 162, which is 0.617, which is 0.62 kg per what? Meter. So when you times both of them together, 397.76 multiplied by 0.62 is equal to what? 246.61 kilogram. So we divide it by 1000 and you're going to be having what? 0.25 tons. So doing this, you measure for your what? Stirrups in your what? Ground floor. So after that, you now have to what? Describe. Mild steel reinforcements as stirrups in the ground floor columns, and then you close. So doing this, you measured for your what? Stirrups in your what? Columns for the ground floor. So with this, we've come to the end of today's video. I hope you derived adequate knowledge from this video. Please, if you did, do not forget to like, share and subscribe to this channel because it helps the channel grow. In our next video, we are going to be treating the block work for this particular drawing. So stay tuned and we will see you.